All right, everybody, welcome. Thank you for coming to today's webinar on Intro to Test-Driven Development. Oh, you're from Lagos. Wonderful. Now, before we begin, a few housekeeping notes. This is a recorded webinar, and that means that anything you write will be public and will stay alive for as long as this video is around. Now, at the end of this webinar, I will be giving out a coupon code for my TDD course. But if you have to drop off, go ahead and drop off. I will also send out a link to the webinar when it's complete. This webinar is slated to take about an hour. I hope to have you out before that. At least on the East Coast here, it is lunchtime, and everybody should be protective of their lunch. Now, thank you all for coming. As I said, this webinar is called Intro to Test-Driven Development. And I really probably should have named it, Is Test-Driven Development Right for Your Team? But naming is hard. So today we're going to be talking about mostly the strategic view of test-driven development. Excuse me. If you look at most tutorials and most ways that people are introduced to test-driven development, they're introduced to the mechanics, the red, green, and refactor, with very little talk about the strategy behind it or when it's even useful. So for this webinar, we're flipping that on its head. We're going to come at it from a strategic view, and along the way, we'll see some of the tactics and some of the minutiae. Now, I do have a course that helps you on the tactical side of it, but again, the strategy is important. TDD is such a thing that you need to decide if it's going to work for you and work for your team. Now, we're going to start out, hey, what is test-driven development? And then we're going to look at the software teams and the people who would use TDD. And what do software teams want? After that, we're going to talk about when TDD is going to be useful for you. In what situations, in what contexts will you get the most out of it? After that, of course, if we're going to talk about one, we have to talk about the other. So we're also going to talk about when TDD isn't so useful. What situations would you not use it? In what context would it not be as helpful? And then we're going to dump into the strategic decisions that TDD can help your team with, how it helps you, how it helps your team from a strategic perspective. Of course, we're also going to talk about problems people run into when they adopt TDD and problems that plague TDD in the community as a whole. And then lastly, we're going to say, great, if all of this is a go and I like TDD and my team likes TDD, well, what's next? And of course, if there are any questions, we will host questions at the end. There is a Q&A chat bubble that you can put your questions into, but I won't be addressing them until the end of the webinar. Now, we're still in the middle of a global pandemic, and I want to be cognizant of that, right? We've all changed. So the things that we're looking at with TDD and with webinars and with our life in general, it's kind of like this. It's changed a lot between lockdown and now. And a little bit about me. Why am I here? Why are we here? Why are we even talking about this? I've been in the software field for about 15 years. I have worked on a lot of different sized teams, from startups, where I was the only developer, to big corporations where there were tens of thousands of developers. I've worked on product teams. I've worked on services teams in various roles. And most recently, before I decided to help teams learn TDD, I was a solutions architect. So I helped companies decide if, what systems to build and how that would best help them. But since 2019, I've been doing this. My business website's at www.doubleyourproductivity.io, which is a marketing pitch for TDD. And really, my hope and my goal is to help teams be sustainable. Help teams avoid burnout. But first, let's start with what TDD is. So TDD is a software practice. It is It was created by, or as Kent Beck would like to say, rediscovered by Kent Beck in the early 2000s as a way to help teams build software. And where it comes from is a way to help you design your system. Now, they called it TDD, test-driven development, but it's really about design. It's really about, how can we build this system better, and how can we build the system in a way that is sustainable. TDD as a development practice is also a way for you to get fast feedback from your users, the people using your software, whether it's another developer who is consuming your code, or whether it's an end user themselves, or whether it's your software manager or your product owner or your project manager. It's a way to give them the ability to give you fast feedback about what you're building. And that's critically important. When you can take something, if you're using Scrum and you adhere to sprints, you may not have anything to show for that whole 2-week cycle until you get to the end of it. TDD gives you a way to show progress within a day, within hours. Gives you a way to get feedback where it's most important to you from your users. And also, while I said it's not a testing practice, it can help you ensure that you won't break your system when you create a new feature. A system that has tests behind it, the various kind of tests that we use, they can give you an understanding of, hey, is what I'm doing, is it going to break anybody? And TDD will help you with that. It's also a way to help your team. Now, incremental progress, constant incremental progress. In software, we tend to, just code and code and code, and we'll have 3 or 4 steps back, 2 steps forward, and then all of a sudden we'll get it. It'll just work. But there was a lot of churning to get there. And one of the things that TDD can help you do is it can help you reduce that churn. Instead of 4 steps forward and 2 steps backward, it can tell you, hey, I'm making tiny steps forward all the time. And if you make a step forward, the most you're going to have to make is a step back. And that's psychologically, that's very powerful. And it's also a way, and this is especially important for me, is also a way to help you keep focus. It is so easy in our companies and on our teams to lose focus, from meeting interruptions to when we work together in person, just people coming by. Even now, maybe the Zoom calls that happen spontaneously. It's really easy to lose focus on what you were working on and to have to pick up all of that mental context again. And what TDD can help you with is it can make a bookmark for you. So you can always say, hey, here's where I was. This is what I was working on, without having to spend 30 minutes getting back into the flow of what you were doing. And more importantly, for the younger developers out there, and for those of us who are introducing ourselves to a new code base, it's also a way to help your team build confidence. And that's, you remember back to when you first joined a team, you were maybe scared that, what am I doing here? How does this work? TDD can help you with that. And it can help the people who are junior on your team, or maybe don't know the code base as well, still contribute very quickly and build their confidence in your code base. Now, okay, so we've talked a little bit about what TDD is from a strategic perspective. Let's now talk about what it isn't. Like, it's not everything. It's not a hammer. Everything is not a nail. So it's not a testing practice. Okay, it's got test in the name. We screwed up. We shouldn't have named it test-driven development. Maybe we should have named it example-driven development or design driven through tests. but we kind of messed up there. And as a result, the framing of it leads people to thinking that it is a testing practice. It's not. It is not a substitute for integrated tests, for end-to-end tests, or automated user-facing tests. It can't do any of those things that those tests can do, nor should it. In your system, everyone has a different context. Some systems rely heavily on third-party APIs. Other systems are purely rules engines. And most systems are just CRUD. Don't expect TDD to take the place of those other types of tests. Every practice has a place where it is most useful. And TDD is not in those places, and those places aren't where TDD occupies. And it's also not unit testing. TDD and unit testing share the name test. And that's it. They are completely different practices. They have completely different aims, and they have their own completely different set of benefits and problems. If I were to rank them, I would prefer TDD over unit testing, but that's because unit testing is implementation driven. When you're writing a test, you are necessarily writing it after you've written the code. So the test is therefore coupled to how the code is implemented. TDD takes the complete opposite tack. And that's why they're not alike at all. So if you ever hear someone using test-driven development or test first against unit testing as being alike, they're not. And we'll get into that a little bit more. But TDD also is not a silver bullet. It will not solve all of your problems. It will not by itself make your life amazing. It'll help, but it won't fix all of the problems that we have. Now, there are two primary types of practices that we use as software teams. And where does TDD fall in those? Well, first vertical I'm going to call is building the right thing. A software team is responsible to build the right thing. And one of those practices that you can use to help you build the right thing, remember, TDD is not a silver bullet. Here are the other practices you can use, is customer research, is calling your customers up and talking to them. And that is a viable way to make sure that you build the right thing, is ask your customers, is this the right thing? Scrum? Scrum can help you build the right thing. Again, it's context dependent, but it is a way to ensure that you're getting the feedback that you need when you're trying to build a system. Hey, am I actually building the thing that you need? And it is light years ahead of where we were before with waterfall. Now, even though test-driven development itself is an extreme programming practice, if you don't know about XP or extreme programming, it is an agile methodology. Kent Beck is one of the creators of it, and TDD was or is one of those XP practices. But there are tons more. Mobbing, having the customer physically there with you, very short cycle times, and there are more. But extreme programming can help your team build the right thing. Now, I don't come at TDD from an XP approach because that's been done. Pretty much everybody that teaches TDD teaches it in tandem with other XP approaches, but that doesn't help you as a team if you can't adopt other XP approaches. So you should be able to pick up TDD without taking other XP practices and still be doing okay. It's also, to build the right thing, you can do lean, where you can set up minimum viable products, MVPs, do the littlest amount that you can get the greatest value out of. That's another practice that will help your team build the right thing. And I would be remiss if I did not bring up the theory of constraints. This is Goldrat's work, a book called The Goal. There's also a software novel based on it called, I believe, The Phoenix Project, that talks about the theory of constraints and how it can help your team produce software more consistently and not burn out. And if you have not read the Phoenix Project or you haven't read The Goal, I highly recommend them both. They open my eyes, and I think they'll open up yours too. There's also, to help your team build the right thing, there are Wordly maps. Ben Mosier, who is at Hired Thought on Twitter, teaches Wordly mapping. And what it is it's a way to show your team where it's at in the context of software development, where your different systems are at, what the economic landscape is around you, and to help you make decisions based on that. And that can help you decide, should we even build this software system or should we just buy it? And continuous delivery. The faster you can get software into the hands of your customers, the faster you can get feedback on it. And CD is one of those processes. And of course, while we're here, test-driven development. Now, there's not just building the right thing, there's building the thing right. And that's what we talk about when we talk about testing, to make sure that we actually build the thing the right way. Now, there's TLA, which is a methodology that allows you to understand code through formal methods. And it allows you to, figure out bugs before you even write code by proving it out through formal methods. That will help you build the thing right. Also, like we talked about before, automated testing, code reviews. You may have varying success with code reviews, but that's another way of ensuring that you and your team can build the thing right. Integration testing, integrating code early and often, testing code early and often with its other pieces. Continuous integration, it's an ancillary process to continuous delivery, ensuring that whatever commit that you have goes into the system immediately, gets run against all the automated tests in the system immediately, so that hey, did I break something? And then test-driven development. It's on both sides. It will help your team build the right thing, and it will help you build it right. Now, all of these practices will help you do those things, but there's one I really want to call out because all of these practices are well known. But one that's not well known in our industry are the impact that diverse teams have on building software. There are studies that show that the more diverse your team is by age, gender, race, background, economic background, educational background, work-life experience, the better software you'll build. And there are studies about this. If you want, there is, this was recently talked about on Agile for Humans. Well, not recently for me because I just listened to it today. It was talked about on the podcast Agile for Humans. It's episode 16. And it actually goes into some parts of TDD, but also how diversity helps teams build better software. But, what are our pains? What do we deal with? And originally I was going to go through this one by one, but I'm just going to list them here because we're in the middle of a pandemic and we're all going through different things. And, these are all pains that we have probably dealt with in the past. And if you haven't dealt with any of these pains in the past, I envy you. But these are just some things that have, kept me awake at night as a software leader, and kept awake people that I know as software leaders. But we're talking about, we've talked about pains. We've talked about the practices that can help your team. But what do teams actually care about? Well, I would say that for one thing, teams don't want to have these pains, right? No one wants to go on a death march. No one wants to get burnout. If you aren't burnt out, chances are within the last 6 months, someone on your team was. And that's a frightening statistic, but it's something to keep watch for. But we as teams, we don't want, these are the negative things, the things that we don't want. So they're always there in the back of our minds. But we also want, hey, if I'm a junior developer, what do I care about when I'm trying to build software? Well, if I'm a junior developer, I care about how do I build this feature? How do I even make this work? That's where their mindset's at because they haven't been in the industry or been on the team long enough to, bring their thinking up. They're just like, how do I do this? And when you go up as a mid-level developer, you start to say, all right, I know how to build a feature. Now, my challenge as a mid-level developer is how do I write the least amount of code to build this feature? How do I make it fit into the current architecture so that people during code reviews aren't like, ha, 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 you did this the hard way. But I hope no one ever laughs during a code review. As a senior developer, you're thinking, does this feature even make sense? Is the system able to do this in a different way? Do I even have to build this? And then when you're an architect, you start to think about the intersection of software and the business. Does this computer system support what our company is trying to do or our organization is trying to do? Does it actually meet the needs of its users and its customers? And when they're different people, does it meet both groups' needs? Now, once you get to the software manager role, where you're a software leader, you start to think more about deadlines. My bosses are telling me that we need this feature in 2 weeks. Can it be done? How do we do it? And sometimes when teams, we don't have the right practices around our work, that'll lead to burnout. That'll lead to late nights. That'll lead to a lot of pain around software development. And we don't want that. Like, no one wants to go through a death march or to be burnt out. But, when you're a VP of engineering, you're not just a software manager, you're the VP of engineering. You're responsible for mostly the whole engineering organization. And you start to think about like, well, hey, I need to add features faster because the business is telling me we need to add features faster. But we got a system that's in production. How do we deal with that? How do we add features faster without committing technical bankruptcy? Now, as a CTO, you start to get away from the software system itself into how your technology helps the organization. How do we meet our roadmap? We laid out a roadmap. Sales says if we meet this roadmap, they'll make their goals. Well, how do we do that? And then finally, as the CEO, your concern is, look, I've got the board of directors breathing down my neck. We're down 18% this quarter. We need to get sales up. But you can see as a software developer, how those concerns at those very high levels trickle down and manifest themselves in different ways to your managers, to your peers, and to yourself. And that's one thing where TDD and some of those other practices can help your organization. It can help make sure that you meet the needs without the pains that we talked about before. So it can help, but let's talk about how useful TDD is and when it's useful. Now, test-driven development is a small practice. It's kind of like learning chess. It's really easy to learn, but it takes a long time to master. And there's only 3 rules of TDD. And any tutorial on the internet will tell you those 3 rules. It's write a failing test, make sure it fails, write a passing test, write the code that passes that test, make sure the test passes, and then refactor your code. That's it. But if it were that easy, there would be no reason to teach it. Everybody would just be doing it if it were that easy. But it's a little more complicated than that, but it has other uses than just those 3 tactical things that we think about when we think of TDD. And the first thing TDD will help you and your team with is how to explore the feature space. So I've been a part of a lot of different companies, and most companies I worked for didn't use TDD. In fact, I would say only one company that I worked for employed TDD in various styles, but made it a part of their standard practices. And that's where I found test-driven development. And it was being used in all the ways that we've talked about, how it, what it's for and what it's not. And so through that, we found, hey, what things should we not use it for? But one of the more interesting things that we used it for was feature exploration. And that is, given a new feature, say, let's say search, what does that feature look like? How does that feature work? How do we design that feature? So every search system on the internet has some sort of syntax that you use. And as a architect or as a designer, you have to think through all the possible ramifications of the search syntax and when people mix it together. One of the neat things about TDD is that you can do that within just a few hours with actual working code, and you can see the effect of it. You can see, hey, do case A and case B conflict? Do these work together well? And it gives you that really fast feedback cycle when you're trying to explore out how a feature should work. It also helps your team make strategic decisions. And what I mean by that are, it's not just enough to have the code that you're working on, the feature you're working on, but it's also a way of understanding, is this feature possible? Not just, here are the tests around this feature, but how will this feature work at a strategic level? For instance, if you have a customer inventory system and you need to build out a new service related to inventory, you have to make a lot of decisions about persistence, about if it's an event-driven system, what events it works with. You have to make strategic decisions around, if it runs a process, how often will that process run? What does that process take in? How does that process interact with the rest of the system? And you can do that just by implementing the code. Absolutely do that. But what TDD will do for you is by implementing the tests that answer those strategic questions you have, you're able to see the effects of it more quickly. And it also helps with your system's design. Remember, TDD, we called it test-driven development. We messed up. Sorry about that. It's really a design practice. It will help you design your system in such a way that you can test the system quickly, which is good, but also that when you build the system, you don't have unnecessary coupling. Parts of your system don't depend upon other parts. And that's really important. With the, I don't want to say the word because it's a dirty word, but with the microservices culture, we're starting to think of systems as loosely coupled services that operate on their own. Now, TDD gives you that even in a monolith. You don't have to embrace a microservices topology in order to have a loosely coupled design. It gives that to you by virtue of running through those practices. It sends you the signal because if a test is hard or a test requires too much setup, it tells you there's something wrong with the design. That's a signal. And it also, back to where we're talking about, hey, business people care about when am I going to get this? Lower level people care about are the people on the ground, on the front lines. They care about, well, can I even make this change? How do I make this change? What if I break something? And that's one of the huge benefits of test-driven development, is that all of a sudden it takes away the uncertainty of building a feature, of changing the system. You know if this is going to work before you kick it out to your CI server or before you have to kick it in at the end of the sprint. And that's that benefit can't be understated. A lot of software development is developing that confidence, and it gives you that confidence very quickly. Hand in hand with that is you're able to show progress very quickly. If I take in test-driven development, the unit is, the thing that I'm testing is at the scope of the consumer, the person who will consume whatever it is feature I'm writing or whatever code I'm creating. So it allows you to make progress very quickly against that. It allows you to say, hey, look, I've just, implemented 4 of the 5 requirements of this feature, and I can prove that they work, and I can show them to you, and you can use them. And that's wild, because the tests are like another user interface. They're a user interface for whoever has to consume your code. Could be an end user, could be another process in your system. It could be another developer who's depending upon your work. And that's one of the chief operational differences between test-driven development and just unit testing. Unit testing, we've always said to people, go to the smallest thing, the smallest bit of code you can. And test-driven development says, nope, don't do that, because that'll be an implementation detail. Go to the smallest bit of behavior in your system, not implementation. And we'll talk a little bit more about that in a minute. And one of my favorite uses for TDD is to figure out how an existing part of the system works. If it doesn't have tests around it, it's very easy, or it may not be simple, but it should be easy to set up tests around it. You may have to use a lot of mocks and stubs in the beginning, but it should be able to suss out for you, how does this feature even work? What inputs does it take in? So I like to tell teams, if you're going to adopt TDD, make sure you adopt it for new systems, but you can adopt it for your existing vintage production systems. But you will spend more time, getting your system under brittle tests at first until you can refactor it to where you don't need those brittle tests. And that's where it helps you extend the life of those systems. If you're a software leader, chances are at some point someone has said, we should rewrite the system. It might have been you. It might have been somebody next to you. I've heard it quite a few times. And typically why teams make that decision is, it's just too hard to maintain this system. Doesn't have tests, don't know how it works, and I'm scared of it. And those are all completely valid emotions. But what TDD can help you do, and help you economically, is it can help you make those systems work for you again, make them a pleasure to be in, and keep the current system around. Joel Spolsky, which is probably the seminal blog post on this topic, if blog posts are seminal, is Things You Should Never Do, Part 1. And in his blog post, he talks about how Netscape rewrote their Netscape engine and effectively lost years and effectively went under because they decided to rewrite their browser instead of using what worked and refactoring it. I've been in situations where teams have rewritten systems instead of, fixing up the old system, instead of putting tests around the current system and refactoring it into an architecture that worked for them. And I have to say, I've yet to see one succeed, whether through business goals, that it be done in a certain time frame, or team goals, that they don't have to make hard decisions that end up hurting them. And if it took you X number of years to write it the first time, why would you expect that it would take any less than that the second time? Avoid a rewrite if you can, and maybe use test-driven development to help you there. Now, those are the things that TDD can help you with. Those are the areas strategically that you and your system or you and your team deal with where it can help you. But it does have some failure modes. Again, as I said at the top, it is not a practice that will work everywhere for all contexts, for everything. It is not a hammer, and software development isn't a nail. It will have failure modes. And one of those is that TDD is a team sport. If I'm working on a system and I'm the only one doing TDD, we're going to have friction on the team, because I'll be writing tests and I'll be writing my code in such a way that it is modular by virtue of how those tests are being written. Other team members may not. Then they start breaking the tests. Well, since they don't care about the tests because they didn't write the tests, they would look at me like, why are you even doing this? And they'd be right. You know, if you're the only one doing a practice on a team, that's a problem. So TDD is a team sport. It requires buy-in at all levels of your software development team. And it's good if you can get buy-in from your managers and from your software leaders as well, but it is a development team practice. But it needs buy-in from everyone. And since TDD changes the way we write software, the old ways of writing code don't work. You know, if your system is written in TDD and they're like, hey, we need an emergency hot patch fix, well, you could just write the code and just do it, but you're going to, do that too many times, and now you're going to cause problems. Since it changes how you develop software, no longer do you get the requirements, write the code, and then test the code. No, you're writing the test for the behavior first. Whatever the behavior is, whether it's fixing a bug or whether it's a new feature. And, I said at the top, TDD has very little adoption among software development teams writ large. I would probably say sub 10%, even though 71% last check of businesses call themselves Agile. TDD, one of the original Agile practices, is only used by maybe 10% of software development companies. And if that's the case, that means you're rewiring the other 90%, right? People who've never seen TDD, use TDD, or care about TDD, saying, hey, you can't write software that way anymore. You can't just throw code together. Sorry, we got to start with a test. We write the code that just passes that test, and then we refactor. So the old ways won't work anymore. And that can be, with any new way of developing software, that can be really hard for people to stomach. Also, if you're going to adopt test-driven development, it's going to take time before you see a return on that investment. And we're saying 6 to 12 months of people, of everyone on your team working together, implementing TDD before you see that huge return. And we talked about the pains at the top. We all want those pains to go away, but it takes time. It takes investment to make those pains go away. But the return on investment is far better than the time you're actually investing into it. So TDD has its failure modes. We've talked about, when TDD is right for your team, when it's useful, when it's not useful. We talked about the things that teams care about. Let's talk about the pitfalls with TDD. Now, I spoke about it briefly, and when TDD was developed, there were two major schools that came out, and one of the schools was called the London School. It sounds a little pretentious, naming it after something like an economics school, but bear with me. And that school of TDD said, hey, we like TDD, but we're going to develop it from the outside in, from the view of the customer. And when I mean customer, I mean at the really top level, all the way down into our system, into the innards of our system. You can think of it as saying, hey, I want to start at the UI and work my way down. And to do that, you have to mock out everything that you don't own in the system, everything that you depend upon, like a database, like a UI, like an I/O process, like another service. You have to mock all of those things out. And what a mock is it's a way of saying, hey, when this actual thing is called, don't call it, but call this mock that I've set up instead. But I want you to verify that that real thing would have been called. Well, one of the pitfalls that teams run into very quickly when they embrace mocks and stubs is their TDD tests and their code are now implementation specific. They're now dependent upon that thing that was supposed to be called. And if any developer changes that thing that was supposed to be called in any way, it will break your tests. Should it have broken your tests? No. The behavior didn't change. The implementation changed. And so if you use mocks and stubs very quickly, you're going to find out that you are now writing brittle tests. That's a bad thing, especially if you want all of your team to adopt test-driven development and not go crazy doing so. And so you have an entire school of TDD where it's not viable, because in a large system, everybody's going to be angry all the time. So one of the other schools of TDD that came out was the inside out TDD, which means I want to go from the smallest unit. And again, they mean unit in the exact same way that unit testing means unit. And that's where some of the initial confusion came from. I want to start from the smallest unit and go outward. And I'm gonna in circles, gradually go outward until I get to that UI. That's a viable way of doing TDD, but it's very easy for teams to over-engineer that code when they do it that way, because it requires you to have tests around the smallest things, around constructors, around each change in a constructor. And that very quickly leads to bloated code that doesn't need to be there. And it obfuscates, what the API, what your code should actually look like to a consumer. And at larger scales, it causes over-engineering in systems themselves. Now, this school of TDD is called the Chicago School, if you're interested. And that's how they approach it. And that's, those are the two major schools of TDD. So that's what we're fighting against. Like, well, I've got one school where I over-engineer things. I have another school where, I have to deal with the pain of mocks and stubs all the time. But also is that as developers, we have a lot of loss aversion. So another pitfall of dealing with TDD, especially when you use the Chicago School, is you feel like those tests that you've created are important and they need to stay around. They don't. Once you have subsumed the behavior in TDD with a if I have a new constructor and now everything's using that new constructor, I should delete all the tests that relied on the old constructor, and I should delete the old constructor. Get it out of there. Doesn't need to be there anymore. But we don't always know when to make that call. So it's very easy for teams to become too attached to their existing tests and not question, should this even be there? Now, one of the other major pitfalls of TDD is that, if you remember, in the early 2000s, object-oriented programming was all the rage. C# came out it came out in 98, but it came out for real with the .NET framework in 2001. Big object-oriented language. Java is a big object-oriented language. And they drove, because TDD came out around the same time, a lot of the ideas of TDD were driven by object-oriented programming. And with all respect to object-oriented programming, it is a very popular bad idea. It is good for some things, but it encourages things like state mutation. I have an object, let me mutate its state. Or it encourages, I need to use very nested inheritance behaviors to make this work. It's become much harder to test. And one of the other pitfalls of TDD is that people focus on the implementation, not the behavior. If anything else, when you go pick up your next TDD tutorial, or you say, yes, TDD is right for me, and I want to learn it, and you pick it up, remember the difference between an implementation and a behavior. If I am teaching, or if I'm writing a program to deal with math, my third grade daughter and my first grade daughter, they're both being introduced to new ways of doing math under Common Core that I didn't know existed. Well, in my old style, I have fact tables, and that's how I would test. I have my inputs, and I know that these outputs happen. Whether or not my program uses that new Common Core algorithm or the fact table shouldn't matter to anyone. None of my tests should depend upon the fact that I'm using a fact table or the fact that I'm using a new Common Core approach. And that's something that we have to keep in mind of when we're writing our own code. We need to test the behavior of the code, not the particular implementation. So where do we go from here? We've talked about what TDD is, how it came about. We've talked about some of its downfalls, the ways that it can help your team, and what your teams care about. Well, if the Chicago school isn't the way to go, and if the London school just causes you headaches, there are other ways. And this is the style of TDD that I picked up. So in 2012, I was on a team where we did TDD, and I was running into the problems that we had with both the London school and the Chicago school, and I was giving up on it. I was frustrated because it didn't seem like TDD would work for large systems. And I ended up going to PyCon, and Gary Bernhardt gave a talk at PyCon that he'd given at the Software Craftsmanship Conference in North America in 2012 called Functional Core and Imperative Shell, or Imperative Shell. The talk itself is called Boundaries, but it's on a style of TDD that takes the best parts of functional programming and the best parts of modern system architecture, like our hexagonal architecture, and it melds them together. And so if you, this talk is well worth watching. It's on his website, destroyallsoftware.com/talks/boundaries is the name of the talk. And in it, he goes into, on a dynamic language though, he goes into how, hey, if you set up your test in such a way that you use the primitives of the language or the types that you have inside of your language that you've created to communicate, and you don't mutate the state of an object ever, you always return a new object changed, or with the changed state, you're able to write tests for far larger systems than you would otherwise. To the point that, inside of this, the functional core of your system, the functional part of your system that actually does all the work, it's all, by virtue of being created that way, it's all got tests around it. Now, 100% test coverage is not a benefit of TDD, even though people say it is, nor is it a goal. But as a nice side effect, you do get a lot of test coverage for the part of your system that actually does the work. And then outside of it, you have very few entry points into that functional core. So one common place where automated tests run into problems now is there are so many different options when you're running an automated test. You have all these different variables that you can set that have effects on the system. Well, in this style of TDD, those are reduced to hopefully a handful so that you're not having to use automated UI tests or end-to-end tests to test these thousands of permutations. And this is where I finally, this is where I finally came into and said, yep. And I started using this style of TDD. And it's worked wonders. Again, I did not come up with it, but it is the style of TDD that I teach, and I believe in it, and I use it. So that is, we're nearing the end here. This has been, hey, this is a strategic introduction into TDD. This will not teach you the mechanics of TDD, nor will it teach you how to apply those mechanics to your systems. But I do have a course coming out in May that will do that. It will take you through this style of TDD for an actual production system. Now, because you came to the webinar, if you use this code, when it's time to sign up, you can sign up right now to get updates when the course is released at course.doubleyourproductivity.io. Now, on that subject, what I do and why I'm here is that I want teams to feel how I felt when, I was part of a team using TDD and how it made our lives better, how it makes software development sustainable, how it helps us. And that's why I started my own company, was to do that, was to help other teams with that. Now, on that site, I will have free content. I do corporate training right now, remote with TDD, teaching the style of TDD. And also, because, again, it's a 6 to 12 month investment, I also offer, should your team want it or need it, remote TDD pairing and advising. That way, hey, not just after that course or after the class, but, going forward, hey, we need a hand, or, hey, I just want to call George up and have him talk me through this program. I'm there. Now, if you want to contact me, I am always available on Twitter at GoreTalk. I have a GitHub, LinkedIn, or I have a GitHub at GoreTalk. LinkedIn is George Stocker. And my site, my personal site, is georgestalker.com. It is very creatively named. And of course, the site you know about now, which is doubleyourproductivity.io. Not mentioned here is I also have 2 podcasts. If you're in .NET, Last Week in .NET, which tells you what happened creatively last week in .NET, and another podcast which is centered around helping teams build better software called buildbettersoftware.fm. So thank you for coming today. It is 12:51. We have 9 minutes left. If you have questions, pop them into the chat. And if not, thank you so much for coming. No questions. Awesome. Oh, one new message. Any examples? Sure, given the time frame. I will actually pull up what I'm working on as part of the course. I am working on 2 things, actually. A budget board, which is something I've been wanting to build for years. And behind that is a recurring, let me see, you should be able to see this. Yes, you can, as soon as my system catches up with what I'm doing. Yep. It's catching up. I am building a recurring date time library. So if you know like Outlook or Zoom, they use, wow, sorry, it is struggling because there's so much going on my desktop right now. If you use Outlook or Zoom, it gives you the ability to schedule recurring meetings. And it gives you the ability to say, hey, these things should happen on Tuesdays or once a month or once a week. And that would be really nice to have encapsulated into a library. And so, especially for a household budget where you need to know, hey, this check comes out, I get paid, for instance, I get paid on the 15th and on the last day of the month. That last day of the month is not always, there it goes. That last day of the month is not always the 31st. February was the 28th. And so if you have a personal budget, then your bills and the things that you worry about have to deal with those issues. And so I'm in the middle of a rewrite, but this is just before the rewrite. And this is when I was starting out. And all these tests, let me make this, all these tests took me very little time to do. From, there we go. From, the time where I said, hey, what should a recurrence, what should it do? Well, funny enough, that the context changed. Is that, I found out when I was in the middle of this, I was like, wow, this is getting, this was easy. So for instance, our weekly recurrence, I just wanted to make sure that, hey, 3 weeks into the future on the 3rd recurrence, it would actually work. And so this is the API. I talk about tests showing you what the API your user are going to use is. Well, for this recurrence library, this is the API. You've got a object constructor, and that constructor takes in, the start date, how often it should recur, and at the point where we stop caring. And that's really because I haven't made a better way to think about dates in the future. Till the end of time, much like you would Conway, or the Conway's Game of Life. But this is the API for that class, and it exposes 2 bits. It exposes, give me the next recurrence, if you want to skip any iterations, and give me all recurrences. If I tell you something happens on every Tuesday, or something that happens weekly, I want you to tell me, when's this thing going to happen again? Until I tell you to stop. And this is the API for it. This is where I talk about testing behavior, not implementation. And in fact, the implementation of this has changed quite a few times. But to answer your question, and I decided, hey, you know what? I'm going to make this enumerable, and I'm going to use link for it, so that way developers who are using it, again, this is for developers. Developers who are using this can use the link things that they care about, which makes it very powerful. But this, you're seeing it at the end state, But all of this came about through those tests, and I am wholly confident in how these work. Now, the rewrite, you're asking, is because I learned more. I was actually at this current test right here. Recurrent set for monthly on a specific day respects that setting. So the first Tuesday of the month, and all of these above, it was weekly, or it was biweekly, or it was, specific dates of months. And I started getting to, well, I want to deal with, every Friday or every Tuesday or every second Tuesday or every fourth Tuesday, which starting to get issues of some months don't have fourth Tuesdays. And so remember when I said, this took me a very short time to do, I was, 4 or 5 hours into this when I hit this example. I'm like, wait a minute. If I set for monthly on a specific day, okay, and I pick Thursday, then it should be the next recurrence, because I'm I'm replacing system time, or I'm replacing date time, because that's notorious hard to test with system time. Then, now I'm starting to get into something weird. And I don't like that feeling. This felt fine, but now I'm going to have a new constructor that says, recurrence period's monthly, but the recurrence period is also a specific day of week. There's several ways to handle that, but in my research, what I found is that there's something called a perpetual calendar. And what I'm going back to do now is I am going to re-implement the system as a perpetual calendar through test-driven development, so that it has its own perpetual calendar, which actually solves these problems. And it's an algorithm for telling you, the first Tuesday of the month or the third Tuesday of the month is this date. Since we're dealing with date times, my consumers care about dates, but we need to expose it as an actual, to the end user, hey, this is the fourth Tuesday, the third Tuesday, or whatever. But the actual computation cares about dates. I have not played with Notatime. I've seen it. I've looked at it. I'm really interested in John Skeet's work with that, but I have not looked at it to use it. And the reason being is because this is for the course, I wanted to keep the primitives of the system or of the stack. And pulling in Notatime and probably cheating with Notatime wouldn't teach how to do TDD, and it would not help with learning the actual mechanics in a real world application. So I hope, Michael Purr, I believe that answers your questions. And Patrick, you said, yeah, I'm in the middle of rewrite. Yeah. So are there any other questions? We are 1 minute away from our end time together. I want to thank all of you again for coming. Thank you. If you want to follow my daily emails, if you go to wproductivity.io, or rather georgestocker.com, you can follow my daily emails. But if you go to course.wproductivity.io, you can actually just get emails related to the TDD course itself. All right, everybody. Discount code. Oh, yes, the discount code is TDD50, and I will show that again. Let me go up. There we go. TDD50, and you can sign up to get course updates at course.wproductivity.io. Everybody, thank you for coming today. And, of course, if you'd like to get in touch with me, there's where you can find me. Thanks so much.